All right, here we have question 4 from the trig area formula, a times b times sine of c divided by 2 questions. The first thing that we have to realize about this question is they're asking for the area of triangle ABD, but A to B to D makes this big triangle here really made up of 2 other ones. The other thing that we have to notice is that we've got to remember some of our angle relationships before we can continue this question. We're given very little information to start this problem. So the first thing that I realize is that I've got a 70-degree angle here, and I've got the supplementary angle right behind it that's not written in. And I know that 2 angles that form a straight line, and I can draw a semicircle across that straight line, these 2 angles have to add up to 180 degrees. So 180 minus the 70-degree angle right here gives me a 110-degree angle in that triangle. The other thing I can fill in right now is that in each of these 2 triangles, I know 2 angles, I can find the third. So I'm going to start over here with 180 minus 110 minus 55, and that 15-degree angle would be this small angle right up here. And over in this triangle, I can find this third angle with 180 minus 48 minus 70. That leaves me with 62 up here. So clearly, if they're splitting this triangle into 2 separate ones, it means that I'm going to have to find the area of these 2 triangles separately and then add them together. I'm going to start over here. So I'll call this triangle 1. And the reason I know I have to start over here is because I have a side length over here. In this triangle, all I've got are the 3 angles. So the goal, working in triangle 1, is going to be to find the length of this line right here, because that's a shared side between the 2 triangles. So the first step would be to find the missing side length right here in triangle 1. So here's my 110-degree angle. Here's my 55-degree angle. This side length is 15. This angle is also 15. That's just a coincidence. And that's all the information I have about triangle 1. But having that information, I can get started with sine law to find what's missing. So I'm going to label my angles, capital A, B, and C, and then my side lengths. Across from angle A, lowercase a, across from angle B, lowercase b, and across from angle C, lowercase c. So the next step would be to write out the sine law, and that says A over the sine of angle A equals B over the sine of angle B equals C over the sine of angle C. So I'll fill in what I know from those numbers. Lowercase a, the side length, is 15 over the sine of 15 degrees is equal to lowercase b over the sine of 110 degrees is equal to lowercase c. That's the side I want to find, though, because that's that shared side between the 2 triangles right here. That's the one I'd like to solve for. So I'll replace lowercase c with x and put it over the sin of 55. Now the fraction with the b's in it is the one I won't use because I'm trying to solve for c, and a is going to help me get there because I know both the values over in a. So here, I'll leave myself some space. 15 over sin 15 equals x over sin 55. Now to solve for x, that side length, which is right here, x, I'm going to cross multiply. 15 times sin 55, 15 times sin 55, divided by the sin of 15. And that gives 47.4744. So 47.4744 is the measure of side length x. That's this one over here. So I can write it in, 47.4744 for that side. Now in triangle 1, I'm actually ready to find the area. So the area of triangle 1 is going to be, now regardless of how I've labeled it, remember the a times b times the sine of c divided by 2 formula requires that I have 2 side lengths and the angle between them so I can find the area. So here I'm going to do this side times the sine of the angle between them. So for area, I'm going to do 15 times 47.4744 times the sine of 110 divided by 2. And that's going to give me area. And when I multiply that all out in the calculator, it's 15 times 47.4744 times the sine of 110, and then that I'll divide by 2 to get an area of 334.585. 334.585. This would be in units squared. So there's an area for triangle 1 over here. Now I'm going to go over and work in triangle 2. That will be this one over here. So in triangle 2, let's make a separation here. In triangle 2, I know all three angles. Here's 48, here's 70, 62, and I know this side length over here, 47.4744. So what I'm going to do is find this side right here, and then I'll use the A times B times sine of angle C to find the area. So the first thing to do would be to label. I'll label A, B, and C, and then I'll have A, B, and C as side lengths. So if I write out my sine law here, A over sine of A equals B over sine of B equals C over sine of C. Little a is what I just solved for, 47.4744, over the sine of angle A, which is 48, equals lowercase b, which is what I want, so I'll put that as x, over the sine of angle B, 62, and that's equal to little c over sine of 70. But right away I'm going to cross this one out because that's not the side that I was trying to solve for. Now over here all I need to do is cross multiply to solve for the x. So I'm going to type in 47.4744 times sin 62 divided by sin 48, and that gives me 56.4054. So 56.4054 is side x. That number goes right here, 56.4054. Now I've got the length of these two sides and the angle between. I can find the area of triangle number 2. I'm going to have A times B times sine of C divided by 2. For these I'll put 56. These are kind of interchangeable, these numbers. 56.4054 times 47.4744 times the sine of that angle between them, 70 degrees, all divided by 2. And that gives me an area of, after I multiply it out, 56.4054 times 47.4744 times the sin of that angle that's between those two sides, 70. And don't forget to divide by 2 at the end. I've got an area over here of 1,258.16 units squared. Now the question's asking for the total area. So I'm going to take area of triangle 2, add it to the area of triangle 1 to get my final answer. So here, as a final answer, I'm going to have area is going to be 334.585 plus 1,258.16. Remember, this was for triangle number 1. This is for triangle number 2. That gives me a grand total area for the whole big triangle ABD, that's 1 and 2 combined, of 334.585 plus 1,258.16. And I get 1,592.745. They wanted nearest integer, so I look beside the integer at the first decimal. Since it's 5 or above, this number has to go up. So my area in total is going to be 1,593 units squared. And that would be the final answer.